Hello. Good morning, Rug. I don't know if you can hear me. Ad break is supposed to be going on. It starts. I have Twitch start that like 3 minutes every hour, like right away. So that way, during starting soon, it can be. Oh, you can hear me. Okay, excellent. Yeah, it's. I don't know who gets ads or not. I don't think anybody gets. I think like one person gets an ad. You got the ad as soon as the stream started. Okay, so basically, what from what I can tell, from what I've set it up, it tries to do a 3 minute ad block right away. And I'm doing the starting soon stream right then. And then of course not everybody gets the ads, which is perfectly fine. I don't mind that much. As long as it does the thing it's supposed to do, which is turn off the pre-rolls, we're good to go. Zilby's here. We're still waiting for the official ad break to finish, and that's when I'll begin the stream for real. Zilby's here. He ate his food. He wants more, so I'm gonna give him another rabbit ear because he finished with all of those previously. So yes, I know you. He didn't know what to do with these for the longest time, and then I think he finally learned he can eat them. So, want this? Oh, it's in this hand right here. Come on. Yeah, don't you like it? Okay. He's trying to rub his face on it in my hand. Okay, over there. And then we have cat. All right, ad break is ending in 10 seconds, supposedly. So we'll go ahead and, oh, you know what? I need to start Steam up for this. Okay, you're going over there. That's fine. And I want you to open. Oh, you're okay. Never mind. You're not. I don't even have the game downloaded on this computer. I need it over here on this computer. I have it. Yes. Launch there. All right, let's go ahead and start the stream on YouTube. Good morning, Twisted Seed. Good morning, Blah, and not really game day. We finished the game. We finished the game officially last week, but we skipped one puzzle. There, toggle full screen. There we go. So I wanted to go over that one puzzle that we didn't get. So first of all, hold on, go live. Oh, hi Zilby. Where is Zilby? Zilby was there. Oh, Zilby. Okay, what happened, Zilby? Hello everybody. Hello YouTube. We are happy Wednesday. This was previously the game day. And we are now doing some more Docker, but I figured that we could do a little bit of gaming. There's Zilby. Okay, so what happened? I gave Zilby a treat right before we went live, and he took it and knocked it off somewhere, and I think he lost it. So I'm gonna go see if I can find that for him really quickly. Oh, see, here it is. Here you are. You can have that. Okay, so in the meantime, let's take a look. So we're gonna look at this. How did I get on a simple sandbox? I wanted to go back to, yeah, full segment list. Let's open up TIS, which there it goes. Okay. So I did a Google search and found on Reddit someone who solved sequence sorter. And so I put that into our Untitled Program 2 for this. Oh, Blah, you're getting some stream issues? What are the issues? I am not, let's see, I'm seeing 3,000 kilobits per second going up, green, no drop frames. So on my side, OBS says everything is fine. Huh, interesting. Well, Blah, if it's still going bad, I have the YouTube stream up. That it might be better there if Twitch is being. I know that sometimes like Twitch has problems in different regions too, where like everything will be fine in one region and then just be complete not fine everywhere else, or vice versa, like fine everywhere but not in one region. All right, so. Okay, and Rug stream is working for you, so that's good. All right, so the very first sequence sorter that I found was this one, which I don't know how they're gonna feel about me. Probably won't ever find out that I'm sharing this out. This is gonna be fine. But the title is "Wow, I'm Such a Hack," but I stayed with it anyways because it works, and I think working is fine. That's the goal of any of these things, right? So without any, we're going to go through the code and just sort of like see how we could have maybe done it, or just how this works in general, because we couldn't figure it out. And a hacky solution is better than no solution. So that's what we're going with. So this is what we got. So let's see what we got here. Now, if you remember, this solution is all about sorting the sequence. The idea is that we're going to take in zero indexed numbers on the left here. Zero index, zero ended sequence. So basically, here's like an array of like 67, 27, 86, 15, and then 0 marks the end. And then for out, we need to have like 15, 27, 67, 86. So it needs to be in order. We need to sort them, and then 0 end the sequence. Now, I was able to sort the very first one, and then it dies. Or maybe not even the first one. And then I didn't get the 0 either. It was bad. We didn't even come close. So this one works completely. So let's go over and take a look at what it's doing. So in our first box here, we have, and if you're not familiar with TIS 100, this is a game. It's a Zachtronics game. It's available on Steam. It's actually pretty cheap. It's like $7 or so. And you can play it by writing assembly code, and each puzzle level is made up of multiple nodes that you can write. They can't scroll in them, so this is as much as you get, and it's assembly code that we write in here. And we have a stack. We have 2 stack memory codes, and that basically a stack is exactly what you think it is. You put something in, and then it stores it, and then the most recent one you can pop off. So exactly. Assembly. I wrote in here with my sort of labels. The one in a link has different labels in there, but these ones make sense to me. So okay, anyways, we start. So we move up into our accumulator. We're moving that accumulator down. So for example, we get 67 in here, and then we move that down, but we also store it in here. We jump into our loop immediately. We then move right to ACC. So move whatever's in here into our ACC. So let's double check to make sure I got this right first. And yes, I did it correctly. Okay. So we jump into, okay, so if you're equal to 0, we jump into loop, right? But this is not equal to 0 because this is 67. So instead we swap. So the 67 now comes here to backup, and backup, which is 0, is now ACC, and we add 1. And then we jump to end. And in end, all we do is swap them. So the 1 comes down to here and is 67 back again. And then we go back up to start again. So if we step through this, we can see that happening. So 67 goes into ACC. We move that down to down here. Are we equal? Is this equal to 0? No, it's not. Swap it, add 1 to that, jump to end, swap it again, and then back up to here again. And it's going to keep on doing this. So we can see we're just moving, we're moving everything down until it's equal to 0. As soon as it becomes 0, we say, okay, hey, we're done with this, right? It's time to end the loop. So we jump into loop, which is now we're going to move right to ACC. So whatever is over here into ACC. And now it's going to wait for that. And then as soon as it finds it, we're going to move ACC down, and then just, if you're not 0, continue on to loop. So we're going to empty out whatever's in the stack memory trace. So that's all and good, but something needs to go inside of here. And that's what happens with the rest of it. So if we take a look up, the next block that we have here is this, the down up labels. So basically we're going to move ACC to down. So whatever that is. Now that starts with 0, right? So we're going to move 0 down to here. And then we're going to move up to ACC. So if you remember, if this, whatever this is that we got up here, we move it on down. So in this case, it's going to be that 67. And then we're going to jump, if it's not 0, to down again. So we're going to, loop this, but it is not 0. So therefore we're going to continue moving things down into it. And as you can see, we are basically just taking this entire series of numbers and throw it in here in the order that they're coming in, including that, starting with that 0. Okay, so this is great. Now, in the meantime, these are waiting. So they're not deadlocked, but they are locked because they're this one's saying, hey, we need to move left into ACC, and this one is move left into ACC, and this one is move down into ACC. So these are each waiting for something to be available to move into it, and none of them have anything in it. So they're just on hold right now. So we'll wait until the sequence is finished, and we get the first 0 coming in down, which is starting now. So we have this 0 here. Swap, add 1, jump to end, swap, move up, down, move ACC down. Okay, so here's that 0 that moves down. We move that into ACC. If you're not 0, go back to down. So we are 0, so it's going to now continue to the up one. So move down ACC. So now we're going to start moving from down back up again. So we're going to drain you and move it to the right. So instead of going back up, it's going to come here and go to the right again. So move ACC. So 15, we popped off this stack. We're going to move it to the right. Here it is, which means that we can finally now work on this here. So on this box, we're going to move left in ACC. So we have that 15, which is the very last item in here. We're going to say, hey, if you're equal to 0, move to end. But we're not equal to 0. So instead, we're going to save it. And save it just means ACC and backup becomes whatever ACC is. Okay, pass. Now we're going to move into this label, move left to ACC. So just keep on doing it. So that's going to be the next one, right? So 86 was the next one popped off. If you're equal to 0, move on to the 0, but you're not equal to 0. So you move on, move ACC right. So move 86. So the second one over to the right. Move, and now let's see, move ACC right. That's fine. Now now we have sort of asynchronous code happening here because like everything is sort of going on at the same time. What's going to happen here is that it's going to swap it. So 86 and 15. And then it's going to move ACC right and ACC right, which means that's going to be 15 right twice. And then it's going to say, hey, I want right back to ACC. So basically we're doing a little swap-a-roo between these two. Now over here, we move left into ACC. If you're equal to 0, we jump to 0. However, this is not equal to 0. So we're going to save it just like we did over here. We're going to sub left. So that's going to, this is about to put the 15 up here and then send it to the right, right? So it's going to sub left. And then if you're less than 0, we move on to bigger because that means that we have the bigger one. So let's see this. So we save use 86 both places. If you're less than 0, we sub left, so that becomes 71 minus the 15. If we're less than 0, we got bigger. We are not less than 0, so we're going to move on to smaller. So now we're going to move left. That's this move ACC right. Move left, left. So we're going to take this and move it straight back to here. So that's the 15 right back over here. Now this saves it, so we keep the 15, and meanwhile over you're swapping so we get the 86 back again. We're now going to move ACC up, so we're going to move 86 up here. And now we're going to wait for this to do its thing. Meanwhile, you are moving left to ACC, so now it's preparing to do its thing again. All right, so you move down ACC. So you're going to take this number and move it into ACC. And then we have a bunch of no operations. And this is the hack. This is the hack that the thread was talking about, which is it's just to wait. It's just a pause. And then we're going to move ACC left. So put the 86 in here. So we need to give these time to run. That's why that's in there. And now 86 gets stored inside of this stack. And if we notice, 86 is the largest of these. So this should be fine. Okay, so next up, 27 is about to go in here, which we notice basically what's happening is that these are saying, okay, you get to pass through here if you're larger, but if you're smaller, you get sort of saved in here, which works for a certain size of these. I think that if we get too many, it won't work anymore, but it solves the puzzle, which is enough for us. And then finally, let's go through until all of them get stored in. Oh, and then move ACC left. Oh, right, because over here, this moves it back over here. So basically, it's just sending this in a loop, which is funny. But then if it goes through all of them, and it thinks it's found the smallest, it then sends it out. So so let's see what happened there. Over here, we move ACC right, move ACC right. So that was the 15 right twice. And then we move right ACC. That was 15 back to here when it was the smallest. We save it, so we have both of them again. And we jump to pass. Pass is then just doing this entire thing again. We're just passing it along. If, however, it was ever equal to 0, then we just want to move whatever we had over to the right. So that would be the 15 because it was the smallest. Swap it, and then we move that down because we have the smallest. So this one is always holding the smallest one at all times. And then that moves down, which this one just moves that down. It just sends it out, which is what we have in 15. For you, we already went through, okay, so we went through bigger. No, I think we went through smaller. So bigger is just the opposite. We move left up because this one's bigger. And then we want to send what we have there. So that way this always has the smallest one, which is it's a brilliant way to solve it. I mean, I think it's a pretty brilliant way to solve it the first try. I'm sure, like, obviously if you try to refactor over and over and over again, you're going to get even better and better and better ways, but this is pretty good. And I think this was the author's first pass to get it working. And first passes for anything. If you get it working, that's good. And so that's it. It should just run through now. And when it hits zeros, it then finishes and drains everything and sends them on through. So let's run this. Half the fun of this puzzle is watching all of the nodes do their thing, especially the stacks. And then we'll go into fast forward mode once we reach the end of these. All right, yeah, so that's all of those. We'll go fast forward mode. And here are the stats for it. So fun. And that's it. We had done all the other ones previously. We're skipping the net because those seem to be more like user created or basically bonus puzzles. We're not doing those. So we finished the core part of the game, which I think is great. So that is what I have. And Sylvie left. Of course he did. He probably wanted more like actual food and not just a treat food. So that's too bad. Maybe during one of the breaks I'll be able to get him back down here and we'll play around with him. All right. So let's reset. We are the main part of the show for today is the Docker course. So now we're going to move on to that. Yesterday we sort of figured out what we're going to do for like the bonus, like the last section. We're moving away. We changed away from Docker in production, and now we're just sort of doing more advanced Docker type things. So this one is going to be Dockerizing Helix, and so we actually did this yesterday. It's a very interesting sort of process to do, to like basically take a CLI program that you want and throw it into Docker to run as an executable, but it does all the things you want. So you basically just wrap all the stuff around it, and now you can run it on any system, and you know that it should, for the most part, run pretty consistently. So for example, we have Helix in a Dockerized form, which means that if anybody wants to run Helix on our system and they don't want to worry about installing it or configuring it or anything else, it just will work on their system. And I don't have very many things installed. It only works with Rust right now, but that should be fine for, like, you know, the course. And of course, if anybody wants more information, like more Docker stuff, I'd be happy to like update it, add more things into it. Okay, so let's jump into to writing this. Okay, Dockerizing Helix. Okay, so in the previous lesson, we've used Docker as an aid for developing. Okay, so there's another way we can use Docker as an executable. Okay, so we're still going to run Docker, still going to run the container with Docker run, but the idea here is that we'll be wrapping a program inside Docker. Okay, so I recommend trying to follow along and then try to Dockerize a program you use. Okay, so what is Helix? Helix is an CLI editor. Should I do the double negative, not unlike, or just similar to Vim or Neo or Emacs? Yeah, similar to Vim or Emacs. Should I do NeoVim? I feel like NeoVim is even more uh more popular of like a term, like more people know about NeoVim than even Vim. Like would people get confused and like, hey, what's Vim? I only know of NeoVim. Ooh, what would people suggest I link to? GNU Emacs? The Wikipedia for it? Maybe, oh, just probably Emacs. This one probably, this one is probably fine. Wait. This corresponds to GNU Emacs version 27. Does that mean wait, which is the Emacs? Is GNU Emacs the Emacs? Okay, maybe I'll just go with this one. GNU Emacs. Okay, so comes with many of the features that we expect out of graphical code editors like VS Code. Okay, so in similar to many code editors, we can configure them to customize the experience to exactly what we want. Oh, did I not put this? Oh, I didn't create a repo for it. Okay, well, I'll need to create a repo for it. Okay, and some of it we can configure them to customize the experience to exactly what we want. All right, before we jump into the walkthrough, before we implement this ourselves, run this command in a directory where you have code. So this is going to be Linux, Mac, Windows. I should verify that. I do have a Windows system. I believe I have Docker running. I should get that updated too. I bet I have a very old version of Docker on it. Okay, starting the Docker engine. Yeah, this is okay. Docker desktop update to latest software update. I am currently on version 4.22.1 on Windows, and the latest is 4.26. Four versions old. It's not too bad. Okay, so for Linux and Mac, we're going to, let's say, I want to cd into a directory where some code exists, and then we're going to run docker run remove it. Do I need the I think I just need the T, right? Volume for that into code, Brook-Circuit Helix. So if we do that, that was interesting, but it worked. Oh, it does need it. Okay, you're right. I do need it to be interactive because I can't control it. Oh no. Okay, yeah, I do need this to be IT. Art went in. Hello. How are you doing today? So I'm interactive with that, and now I can do all the things in here. We can open you up, and we can take a look at it. So this works here. Now for Windows, you're not, okay, so update and restart. Yes, please. Today is a weird one. You're at 5% energy throughout the entire day, but you're pretty productive. Hey, that's pretty good, right? I mean, does it at least feel good to like be productive? It always feels good to me whenever I'm productive, regardless of whatever my energy level is. Oh, okay, so this might take a while to update Docker for Windows. Okay, so while we're waiting. Okay, so will be dropped into a editor. Use space nope. Use space F. Use space F to open the file menu and hit enter to open a file of your choice. Yeah, it feels pretty good. You did more than planned today. Nice. That doesn't happen too often lately. There's a really cool thing that I don't know if this is gonna work for you. It works for, I know it works for a lot of teams in sort of like more like a professional environment. So I don't know if it works like outside of that. But there's this ironic thing where if we put less on our plates, so we limit the amount of work in progress and the amount of work in our to-do column, we end up getting more done as long as we allow ourselves to pull from the backlog throughout the day and the week. It's so weird, and it's counterintuitive but that's how I can consistently get more than I want done, is by having less stuff in front of me to do. All right. Will be dropped into an editor. Use space F to open a file, and hit, I guess like it's space F to open a file, and hit enter to open a file menu, and hit to open the file of your choice. If this is a Rust project, the LSP, the language server protocol, will load and give feedback. Currently, as of what is this, 2024 01 31, this okay, the configuration only supports Rust. Okay, so currently the configuration only supports Rust. Okay, that's great. We do that. And use Vim motions to move around. So what is that? That K for up, K is up, J, oh, the lowercase. So K is up, J is down, H left, L is L, yeah, L is right. I do it just so from memory now. I don't even remember what they are. I remember when I first learned this way a long time ago. The thing that was taught to me is the way that you remember that up is that K is reaching for the sky, so it's going up. J is digging deep into the ground, so it's going down. H is on the left side of your home row, and L is on the right side of your home row. So they're going left and right, respectively. Yeah, I practiced that for a long time now. I use a practice I read about in the Make Time book. At all times, there's one thing in the front burner, main priority, and the back burner, second priority. Everything else goes into a so-called kitchen sink, and things that I might do go into might do list. Similar to Eisenhower matrix, kind of. Works pretty well, apart from times when I randomly get sucked into experimenting with new shiny stuff. Ain't that the truth? It's our brains are like the worst and the best, right? Because so often like we figure out a system and it doesn't matter how good that is, how long we've been working on it. It's just like, ooh, you know what? I've been pretty good. Let's just do it differently this one time. Come on, let me do this. It's almost like you have that little you in the back of your mind go like, come on, this one time. Let's change chapter. Let's chase the shiny. The shiny is gonna be good. Come on, I'll give you lots of dopamine. And then we do it and we feel like shit later because we didn't get anything done. Okay. Yeah, I feel like the dog from the Up cartoon sometimes. I think we all are the dog from the Up cartoon sometimes. All right. You can use Vim motions to move around. Okay, so that's that. When you're done, press. I'm just gonna say, no matter what you're doing, press escape colon q return to exit out. I have to assume that there's people in here that don't know Vim and are going to be confused by this, especially since like the number one upvoted question on Stack Overflow is how do I quit out of Vim? Although I do believe that probably most of those upvotes are ironic, joke, fun, haha upvotes. You know, for the memes. Skimus, hello. Good morning. How are you doing today? You reopen the terminal, right? Yeah, you just quit the terminal. I mean, I'm pretty sure that Emacs, for Emacs, what you do is you just set that in your RC file to just load Emacs when the terminal opens, and then it's your life. So there is no quitting Emacs. The shutting down the terminal is like you basically stopping using it temporarily. Oh, you might want to add in a queue. Yeah, that's a good point. Queue in case they did something. Queue bang, return to exit out. That's a really good point. Okay. All right. We're doing that, and we don't need to, I guess like this is an example of how we can put a program into Docker and run it without having it installed on a system. Art went in. You're heading out. Well, thank you so much for stopping by, and I hope that you have a great night. And we'll see you next time. Okay, so this example, let's go ahead. In the following sections, we'll be recreating this ourselves. Okay, Windows. I want to verify that this works because we took it at face value yesterday, but if I do put it in here, it would probably be a good idea for us to, like, you know, double check it. So what do we have? I have main. Yeah, okay, so this is my Windows computer. There we go. Let's go ahead and open up a new shell. It's a standard PowerShell, and I want to find some code. Documents, code, Brooks builds. What do we have in here? We have let's go to our, let's see, Learning You. Maybe that's a good one. Oh, I keep on forgetting that tab autocomplete is very different in Windows. All right, so we're gonna do a also I can probably whoa, it's not what I wanted. Okay, so Docker run, we're going to rm to remove it automatically. We're going to use it, we're going to volumes, and so it's curly brackets for pwd into code, And then this is going to be Berserker Helix. I mean, I'm also assuming that, oh, I did PWD in all caps. That might not be correct. I wonder if it's lowercase PWD. And if that's not it, I'll have to do something else. Okay, so we have you. I don't have Helix installed on this Windows system. So it also goes ahead and shows, okay, so yeah, this works. This works exactly as you would expect. Okay, cool. Case insensitive in Windows, right? Yeah, I guess it is. So then we just say we want to quit out and we're done. So yeah, okay. Go back to you. And everything exactly the same, except you're that. Okay, case insensitive, so this PWD can stay lowercase like that, and then it just works. Okay, creating it ourselves. What is, okay, so we did what is Helix, so now the Docker file. Okay, so the walkthrough, we're just gonna walk through the process of creating this. So walk through the process of walkthrough. Just name walkthrough. All right. This when creating a Docker, like a wrapper, a Docker image that wraps around a program, we need to begin with the end in mind. Oh, and ads are going to start in around 5 minutes. We'll probably just keep on working through this one. Okay, so when creating a Docker image that wraps around a program, we need to begin with the end in mind. In this case, we want to we want to put Helix. As I do a lot of, I think personal pronoun is fine here because it's now talking like as me. So as I do a lot of Rust development. Okay, we're gonna get it working with Rust code. Okay, step 1. First, we're going to create a repo. There are private Docker repositories. Like the only private Docker repository that I've used and am like somewhat familiar with is ECR, Elastic Container Repository. And that costs something like one. It's to me, it's like not. I definitely don't want to use it unless I absolutely have to. I use it at work for Dockerizing our like the private code for, you know, the employer. But I generally don't want to do anything else. Pudada, hello. How are you doing today? Isn't GHCR better for learning? What's GHCR? GitHub. Oh, GitHub Container Repository. Oh, yeah, they do have one. They do have one. Okay, so I totally forgot that I have one. Also, huh. Right. I didn't realize that that was the domain for it, for GitHub packages. Oh my gosh. Automod. Okay. Automod is so weird. Sorry about that. Yeah, no, you're right. But I'm not actually using that. I'm basically saying like it, right? So this one is probably a better one to do. So here, we'll do this. So there are private Docker repositories like GitHub container repository. Sure. Yeah, I guess it starts with Docker there, so that's fine. Automod hates you overall. Oh, I'm sorry about that. It's Automod, I feel like, has a field day with programming streams the most, right? Because people are like posting links, people are posting code snippets. Code snippets have dot in them a lot, and so it thinks that everything's a link. It's fun. Okay, so there are private Docker repositories like this, which may and the ad break just started. I'm gonna work through this, but if you do get ads, I'll see you on the other side.